Okay, class, this is for our notes for our probability review. Okay, the first thing we're going to look at is the fundamental counting principle. Remember, the fundamental counting principle says that if there's A ways for an activity to occur and B ways for the second to occur, then there are A times B ways to occur. So the first example I'm looking at here is like, in how many ways can you arrange a shirt on 8 shirts on hangers in closet? So for the first way, on the first hanger, you have 8 choices. First hanger is 8 choices, and then you have 7 choices, and so on, all the way down. So this would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or you write this as 8 factorial, which 8 factorial is equal to 40,320. Okay? Another thing we talk about fundamental counting principle is with repetition or without. So the example here says a town has a telephone numbers that all begins with 329 followed by 4 digits. How many different phone numbers are if we can repeat? So if you can repeat, remember you have 10 choices for the first digit, then you'll have 10 choices for the second, and then you'll have another 10 choices for the third, and then 10 for the fourth. So this would be 10 times 10 times 10 times 10, which gives you 10,000 choices if the numbers can be repeated. Now on B, if you can't repeat it, you have 10 choices for the first one. That one's out of the question. You can't use that anymore, so then it's going to be times 9, times 8, times 7. And then if you multiply that out, you get 5,040 choices. Okay, the second thing on the probability review is permutations. Remember, permutations is when order is important. Okay, order is important on these. It's like when you're running for office, you only have one way you can get, like president, vice president, and things like that. So in this one here, it says in how many ways you have 8 teams are competing in a baseball playoff. This first one here says in how many ways can a baseball team finish the competition. Alright, order is important here, so you're not going to have repetition. So there's 8 different, you have 8 ways that they can come in first. Then they have 7 ways they can come in second because the first place is out. And then 6, and then 5, 4, 3, 2, 1, which is like we had in the first one, which would be the same thing as saying 8 factorial, which would be 40,320. Now on B, this is where order is important. You can only have first, second, and third. There's only 3 ways to figure this out. So you would write this as 8 permutation where you're picking 3, and you would plug that into your calculator using your stats button, and then you would get that there's 336 ways for this to come through. Now if you didn't have a calculator, you can always use this rule where you would have 8 factorial all over 8 minus 3 factorial, which would be 8 factorial over 5 factorial, which gives you 8 times 6 times 7, 8 times 7 times 6, sorry, times 5, and then you would have 5 times 4. These would cancel and you wind up with 8 times 7 times 6, which should give you 336 the same way. So if you don't have a calculator, you can always use this formula that's been given to you. Okay, think of an example of permutations I'm going to give you. Say you have 6 homework assignments over the weekend to complete, and you only have time to complete 4 of them on Saturday. And it says, in how many orders can you complete 4 of the assignments? So this is where order is important, because once you do an assignment, you're not going to redo it. So this would be where you have 6. It's a permutation where you're going to choose 4. So this would be 6 factorial all over 6 minus 4 factorial, which would be 6 factorial over 2, or plug it into your calculator, and you should get the answer. If we continue, the answer you should get if you continue with this would be 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1. These cancel, and then you can just multiply this out if you don't have your calculator. If you have your calculator, you know how to use it, plug it in. And we get 6 times 5 is 30, times 4 is 120, times 3 would give you 360. on that. But remember, if you know how to use your calculator, then we should just go ahead and use our calculator for those. So most of you have the TI-35s or calculators like that where you know you're going to use your math button, tab over to probability, tab down to, first of all, hold on, got to put the number in first. So we're going to have a 6 first. Make sure you have your 6 in there. And then you're going to tab over to use the math button, tab over to probability, down to the second one, hit enter, and then you have 6 and you're going to choose 4, hit enter, and you get 360. So it's the same thing. So just make sure you know how to use the calculators. If you need help in class, ask a friend or ask me when I'm here. Thanks. Alright, the next thing we're going to look at is combinations. Remember, combination is when order is not important. Order is not important on this, okay? So I'm going to write that down. So I wrote that down, order is not important. So in how many ways can you choose 8 students out of 30 to participate in a study? So this would be a combination where you have 30 to choose from and you're going to take 8. Alright, so then again we would just plug that into our calculator. If you wanted to do the long way, you would have 30 factorial all over 8 factorial. 30 minus 8 would be 22 factorial. Okay, and you can do it the long way if you wanted to. Otherwise, you can plug it into your calculator and you would get the answer. Okay, so we plug that in and we get 5,852,925 ways to pick 8 students out of 30 to participate in a survey. The next topic we're going to review is probability. And remember that the probability of an event happening is a ratio between the number of times the event occurs over the number of trials. So in this case, the problem says the softball player got a hit in 20 of her last 50 at bat. What is the probability she'll get a hit in her next at bat? Okay, so I would write this as the probability of a hit would be equal to the number of times the event, so that's 20 out of the number of trials would be 50, and 20 divided by 50 is 0.40 or 40%. So that would be her the probability that she would get a hit the next time she's at bat. Okay, so we have another example of probability. So this one asks what's the probability of getting a sum that is an odd number on one row of 2 fair number cubes. So I wrote out here all the possible outcomes. So if we added these up, you would see that you have 36 possible outcomes here. I didn't finish this. It would be 7, 8, 9, 10, 11, and 12. So I have right here, I have 36 possible outcomes when I roll the dice. And it's asking me what's the probability of getting a sum that is an odd number on one row. So if I look at here, and if I circle all my odd numbers, that would tell me what my odds, my number of odd chances, number of rows that would give me an odd number. Okay, so if I count up the number of odd numbers that I circled, I wind up that I have 18. That would give me a sum of an odd number out of 36. So that would be 0.5, which would be 50%. Okay, so remember the probability when you look at things, the probability of an event occurring is the number of times it occurs over the total number of trials. Okay, so we're going to look at the probability of independent events. Remember, if you have an independent event, one outcome does not affect the other, and then you would take probability of A and B, and then you would multiply those two probabilities. If you have a probability of A or B happening, you have to ask yourself, are they mutually exclusive? So remember, that means that cannot happen at the same time. So if they're mutually exclusive, you would add them. If they're not mutually exclusive, or they can happen at the same time, you would have to add the two probabilities that they're both going to happen and then subtract out the probability that they both happen. So let's look at the first example. So it says you roll a 6-sided number cube. What is the probability of rolling a 2 or a 5? So is this mutually exclusive or not mutually exclusive? Can I roll a 2 and a 5 on the same row? And that would be no, it cannot happen at the same time. So I'm just going to add the probability that I roll a 2 plus the probability that I roll a 5. So both of these are going to be 1/6. So the probability that I roll a 2 is 1 over 6. The probability I roll a 5 is 1 over 6. So that gives me 2 over 6, which is equal to 1/3. 1 divided by 3 is 33%. So that would be the probability that I roll a 2 or a 5. Alright, example 2 says you roll a 6-sided number cube. What is the probability of rolling an odd number or a number less than 3? Alright, so if I think about this, an odd number, my odd numbers are 1, 3, and 5. And then my numbers less than 3 are 1 and 2. So this is one of those ones where it is not mutually exclusive. I can roll a number that is odd and less than 3. So I'm going to have to take the probability that I roll an odd number. I'm going to add the probability of rolling a number less than 3, and then I'm going to subtract out the probability of both, that I'm odd and less than 3. Alright, so the probability that I'm going to get an odd is going to be 3 out of my 6 possible outcomes. The probability that I'm less than 3 is 2, because I can get a 1 or a 2. And the probability that I'm both odd and less than 3 is only 1, is a 1. So it'll be minus 1 over 6. So 3 plus 2 is 5, minus 1 would give me 4 out of 6. And 4 divided by 6 is 2/3, which is equal to 2/3, which is equal to 66.67%. Okay, so that's an example of independent events. Okay, so remember we're going to compare independent and dependent events. Independent is when one outcome doesn't affect the other, and dependent is when it does. So this one says you randomly select 2 marbles from a bag containing 15 yellow, 20 red, and 12 blue. What's the probability that the first marble is yellow and second marble is not yellow if you do the following? Alright, so first thing, let's add up all our marbles. Okay, so I have 15 yellow, 20 red, and 12 blue, so that gives me 47 marbles all together. And A asked me that you replace the first marble before selecting the second. Okay, so I'm replacing the first marble before selecting the second. So the probability that I select the first marble is yellow is I have 15 yellow out of 47, and then we'll be multiplying. So, and the second marble is not yellow, so that would be 32 out of 47 because I put it back in. Okay, so if I multiply this out, I get that 15 times 32 is 480, and then 47 times 47 is 2209, and divide that out, and I get that the percentage is equal to 0.217, which is equal to 21.7%. That is for A. Now for B, it says I did not replace the first marble. So the odds for the first one doesn't change, it's 15 out of 47, but the second one, I would be 1 less marble in there, so I'd have to do it this way. You subtract out the one that you did not put back in. Okay, and I just continue with the multiplication. 15 times 32 gave me 480, 47 times 46 was 2162, and divide it out, and I get that it's 22.2%. Okay, so the last example we have is the conditional probability. So this one is asking me to figure out, the table shows 200 students. They want to know the probability that it is female for A. So we'll look at that one. The probability that you have a female is equal to the number of females over the total. So if I added up the females, I get 120. Total is 200. So 120 divided by 200 is 0.6, or 60%. Okay, part B is asking me what is the probability that it's female given that they're full-time. So that's going to be the probability of female and full-time all over the full-time total. Okay, so female and full-time is 40, full-time is 60. You divide 40 by 60, and I get 0.67, or 67%. Alright, continue working on the practice problems. If you have any questions, save them for Thursday, and have a good night. See you on Thursday.